In this video, we're going to start by doing just a flowchart proof. And since it's our first one, instead of writing down the statements and reasons ourselves, we're going to get them from an envelope which has the ones in them already. So I've got number one, I've got envelope number one, and I'm just going to pour out all of my different reasons and make sure that my envelope has nothing left there. All right, hopefully we can read this in the video okay. So I'm just going to take all of my statements and reasons, and I'm going to put them upright so we can start looking at this. While I'm doing that, let's take a look at our givens and what we want to prove. I am given that D is the midpoint of line segment AC, that BD is perpendicular to AC. I'm also given this picture to help me think about it, and I want to prove that angle A is congruent to angle C. All right, so first thing I'm going to do is just look for my two givens and I'll start putting those down. Well, I'm going to have a given over here, so I'll put this given over here. Let me zoom in a little bit so we can see something. All right, found a given over here, I'll put that over there. My second given is going to go on this part of the flowchart. All right, well now D is the midpoint of AC. Here's one piece of information, and I guess I'll start out with that in this first part over here. Great, so D is the midpoint of AC, and the reason I can say that is given. Next, BD is perpendicular to AC. That's my other given, so I'll put that in this top part of the flowchart. All right, let's keep moving on. So if D is the midpoint of AC, what information is that going to give me? So let's see, is that going to mean side angle side? Not really. Is that going to mean that angle ADB is congruent to angle CDB? Well, this is, D is a midpoint, so it's not anything about an angle being bisected. Nothing there. BD is equal to BD. That's going to be a reflexive property. Maybe I'm thinking about putting that in that start of that flowchart over there. Let's keep going here though. Perpendicular lines form right angles. That sounds more like a reason than a statement. So maybe I'll start putting my reasons over onto this side. My statements are up here. Let's see. AD is congruent to DC. Well, so if D is the midpoint of AC, then that means, yeah, well, AD is going to be congruent to DC. So that's there. And the reason I can say that is, a midpoint divides a line segment into two congruent segments. Maybe I'll bring this up closer to the camera. It's not showing up well. A midpoint divides a line segment into two congruent segments. We had it for a moment. Well, that'll be my reason over there. And you can basically think of that as just the definition of a midpoint. All right, and it looks like that's all I need to do for my midpoint part. So now I'll keep going on from what I get from perpendicular. If BD is perpendicular to AC, BD is perpendicular to AC, well, I know that means it's forming right angles. So this angle is going to be right, and this angle is going to be right. Let's see if I can find the matching thing over here. Oh, look at that. ADB and CDB are right angles. That's exactly what I just said. And the reason that is the definition of perpendicular lines, or the fact that perpendicular lines form right angles. So that'll be my statement and my reason for this box right over here. Now, what do I get after that piece of information? Well, if these are both 90, that means that they must be equal. So I can then say this thing from before, that ADB is congruent to CDB, and the reason of that is really the definition of right angles, or just the idea that all right angles are congruent. Because if you're right angle, that means you're 90 degrees. So if both of these are right angles, that means they're equal. All right, let's go over here. We already have in this box, BD is equal to BD, and we said before that was the reflexive property. Great. We're moving right along here. Now, let's see. I want to prove eventually that angle A is equal to angle C. I just did BD is equal to BD. So I have nothing that tells me anything about angle A and C yet, but I do know, because of side angle side, that ADB, triangle ADB, is equal to triangle, or congruent to triangle CDB. So I can put that in this box right over here on the bottom. Oops, the very, very bottom. Let's move it up this way like this. That triangle ADB is congruent to triangle CDB, and that's by side angle side, like we saw in the picture up here. Well then finally, I know if these two triangles are congruent, I know that every single part of them that corresponds is also congruent. So that means if these two triangles are congruent, angle A is corresponding with angle C, so that means that angle A must be congruent to angle C. And that's exactly what we're going to say in our very, very final box over here, is that angle A is congruent to angle C, and that is by this reason over here. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Well, that's what we just said above there, right? That if I have two congruent triangles, the corresponding parts of those triangles are also going to be congruent. And so that is it for this flowchart proof with the statements and reasons given to us. I hope that was helpful.